Hey guys, a wonderful day. So for today, we are going to be learning on Newton's first law of motion. Okay, there's three Newton's law of motion that we are going to learn. But for today, our focus is going to be the first law of motion. We are going to do all calculations related to forces based on the first law of motion. Now, before we move on to the calculation part, we got to know what does the Newton's first law of motion states. Okay, so basically, the Newton's first law of motion states that an object at rest will remain at rest or continues to move with uniform velocity in a straight line unless it is acted upon by a external force or forces. Okay, I repeat, Newton's first law of motion states that an object at rest will remain at rest or continues to move with uniform velocity in a straight line unless it is acted upon by a external force or forces. Okay, so there's a specific formula over here. The formula that we're going to learn for today is net force, okay, or summation. Basically total lah kan, equals to 0. Sebab they said will remain at rest or continues to move uniform velocity. You guys know F equals to ma kan? Kalau uniform velocity, acceleration jadi apa? Kosong. That's why equals to 0 over here. Okay, unless it is acted upon by a external force or external forces. Okay. Now, let's have a look at a couple of details that we need to know before we move on to the actual calculation part. Okay, let me open up a new page. The things that you guys need to know. Number one, I'm going to use purple over here. Number one, inertia. Inertia is a tendency of an object to resist any change in its state of rest or motion, and it's also a scalar quantity. Okay, let me repeat that inertia is a tendency of an object to resist any change in its states of rest or motion. Okay, basically to resist movement, right? Okay, next. Number two, mass. Mass is a measure of a body's inertia. It is a scalar quantity, unit, kilogram. Okay, this is non-dependent on location. Apa maksud dia? You guys know dulu, you guys have done the differentiation atau diminish between mass dengan weight kan? Kalau weight, dekat tempat-tempat lain, it's different weight. Kalau mass, dekat mana-mana pun, mass dia akan tetap sama. That's what they mean. Non-dependent on location. Okay. So, if mass increase, inertia will increase. That's a relation and very important relation for you guys to know. Okay, now let me get back to the first concept. What do they mean force net is 0? You guys know all the forces that we have learned kan? Tension, weight, external force, normal force and so on. Okay, so basically what they mean here is tambah semua ni akan jadi kosong value dia. Sebab and only if the question states at equilibrium, at rest atau stationary. Okay, walaupun the thing is move, the moment you can see keywords like uniform velocity, equilibrium, at rest, remains at rest and so on, that means total of forces equals to 0. And over here, jangan lupa positif dengan negatif anda because forces is a vector quantity. Okay, now let's have a look at some examples for you guys to get to know well on calculations based on the first Newton's law. Okay, let's have a look at this question. For this question, the diagram is given. Okay, gambar rajah telah diberi. Okay, so you guys know what to do very well. Okay, so let's have a look at this question. This diagram is drawn. I think you guys are quite clear with free body diagram, kan? Okay, you guys, it's up to you to redraw the free body diagram, F1, F2, F3, because it's going to be the same thing as this. Sebab ini kan dah diberi dalam free body diagram. Okay, so you just follow whatever needed. Remember, angle always towards the x-axis. Remember that, okay? Okay, now, calculate the magnitude and direction of a force that balanced the three forces acted at point A as shown in figure 4.29. Okay, basically to balance the force, which means something which a point or a force which balances all three of these forces, bila tambah akan jadi kosong. That's just the simplest meaning you can ever get. Okay, so now to answer these kind of questions, there's a technique. So what do we call the technique? The technique over here is called the table of forces. Okay, so what do you do in the table of forces? You gotta buat table dulu. Dia macam stuva but not exactly stuva, okay? So over here it will be forces. Here will be your x component, here will be your y component, okay? Now, it's up to you. There's two ways. Number one, you can write the unit dekat atas sini, Newton, sebab forces kan Newton, atau you guys nak tulis dekat dalam pun boleh, okay? But make sure you guys write unit, very important. Sebab all these kind of tables give you marks actually. Now, so what do you do? Sini kan ada tiga forces, F1, F2, F3. Just write it down. F1, F2, F3. Okay. So, what do you do next? F1, let's go one by one. F1 is 12 Newton. Tapi X component dia apa? Dekat sini kan? 12 cos 55. So, you just write down 12 cos 55 degrees. Next, for the Y component, 12 sine 55, okay, degrees. Next, F2. F2 is over here. 20 cos 30 is for the X component. Remember, it's going to the left, X component. So negative 20 cos 30 degrees. For the Y component, it's negative 20 sine 30. Okay. Next, F3. F3 for the X component is going to the left. Negative 30 cos 45 degrees. For the Y component is going downwards. Negative 30 sine 45 degrees. Okay. No. I'm sorry. Now, what do you do? Close the table. Okay. Okay, there's no space at the bottom. So what you actually need to do is, you have to do, sini kan tadi F1, F2, F3. It's actually the same table. It's just that no space dekat bawah. So I just draw over here. So you close the table. You put an F over here. Okay, this F represents the total force. Okay, tapi ingat, you can do total force juga lah macam ni. Okay, total force untuk apa? X component, Y component. Okay, one by one. So you calculate all here. Ingat negative positive tau. Then you tambah semua. You will get a value over here. This is what we call F, total forces in the X component. Same thing for Y component. Tambah semua. Ingat negative positive. Here you will get Fy, which is the total forces in Y component. Next, what do you do? Okay, you guys know very well, we said that it is balanced the three forces, basically in equilibrium atau Newton's first law. So, EFX equals to 0. EFY pun kena equals to 0. Okay, so I'm going to skip a step. I'm going to give you guys the answer straight. What you guys need to do is show me step by step. Alright? So, tadi kita buat table kan, dekat bawah sekali EFX atau total of FX equals to 0. So, you will be getting an equation over here. Sebab, kalau you guys realize dekat sini, Sini ada value, sini ada value, sini ada value. Sini ada tak value? Tiada kan? Tapi total dia kosong. So, you'll be doing this. You'll be getting fx equals to a certain value. Basically, carilah fx dengan cara tambah semua ni. You get EFX, okay? Tapi ingat, you have to put it in equilibrium. EFX equals to 0. Baru tambah semua ni, cari what is fx, okay? Same thing for your fy. Fy equals to 0. Same thing over here, you have to find how many Newton is Fy. Basically, sini walaupun kosong, kena cari tambah, you will get the value of Fy. You have to show us these two things. Sebab this is Newton's first law. Okay, cari Fx, cari Fy. Now, dia cakap apa? Magnitude of forces. You guys know very well what to do kan? Resolve vectors. Resolve vectors, same thing. Fx square plus Fy square. It's just Pythagoras theorem. Dapatkan jawapan forces yang sebenar in Newtons. Direction, benda sama. Theta equals to tangent inverse Fy over Fx. You will get your angle. Okay, I'll give you the final answers. You have to show me how do you get the answers. The force, basically the magnitude of the force lepas you resolve is 31.6 Newton. And the angle is 2.48 degrees. Okay? Alright. Now, that is for the first example. The first example is quite direct. It's just to show you and emphasize to you the Newton's first law. Now, let's have a look at the second example. Okay. This time, it's descriptive. Maksud dia tak beri gambar raja. So, what do you need to do? Macam biasa, sketching. Okay. Let's have a look at the question first. A load of 250 kg is hung by a crane's cable. The load is pulled by a horizontal force such that the cable makes a 30-degree angle to the vertical plane. Okay. Yang penting is 30-degree angle to the vertical plane, which means ada plane dekat sini kan? It makes a 30-degree angle. Okay, vertical plane. It's pulled by a horizontal force, which means it's somewhere here. Crane. Kalau crane, of course dia akan tarik benda tu kan. So a load is hang here. So this will be your diagram. Okay. When the crane tengah tarik and it's 30 degrees moving to the right, which means your force is moving to the right. Okay? Because a crane is carrying that load, you know. So that crane is moving those load left and right. And right now it's making a 30-degree angle towards the vertical plane. Jadi, secara logik, crane tu memberi external force untuk that load to make a 30-degree. Sebab kalau crane tu tak bergerak, confirm bola tu akan dekat sini je kan? Takkan ada angle. Tapi sekarang ada angle, which means there's an external force exerted by the crane so that the ball can make, atau the load can make a 30-degree angle to the vertical plane. Now, let's have a look at the free body diagram. Okay, you guys know very well this is happening over here. So what do we do next? The beauty of physics is whenever something is downwards, okay, benda ni downwards kan, automatically we have to draw a Cartesian plane over here. You guys know Cartesian plane kan, belajar dekat mathematics x and y axis. Sini x, sini y. Okay? So what do you do? Kan force dekat bawah. The moment it's downwards, bring it up. What do you do? Make the diagram upside down so that everything is above the x-axis. Okay? So that everything is above the x-axis. Therefore, your free body diagram will be like this. External force definitely towards the right. Okay? Remember the dot. Okay? Weight force definitely down. Next, you will have your, sepatutnya tension dekat bawah kan, tapi remember for physics is to flip whatever which is down towards up. Kalau dia belah sini, just tarik dekat atas. Okay? Atas, tension. Okay? Alright. So you have X and Y axis. So remember, lepas you tarik, you must identify dekat mana angle dia. Kalau sini 30 degrees, secara matematik, sini 30 degrees kan? So sini will be 60 degrees. Kenapa 60 degrees lebih penting daripada 30 degrees? Sebab we want angles which is always towards the x-axis. Okay? Now, let's do the calculation. Okay, before I move on, please bear in mind, if the load is in equilibrium, automatically Newton's first law. Summation of F equals to 0. Alright, let's have a look at the calculation. How do you do so? As usual, dapat soalan table of forces. So you'll be doing table of forces over here. Here will be your force, here will be your X component, here will be your Y component. Please write units. Units are very important. First, weight force. X component. Ada tak? Tiada kan? Only Y component, right? I think you guys are quite clear on this part because we have discussed this many times. Which one has X component, which one has Y component. Okay. Now, weight force untuk Y component here ada negative W kan sebab dia downwards. So, just tulis negative W. You nak buat macam ni pun boleh. Negative mg. Kenapa? Remember always, W always can be expanded into mg because W equals to mg. Okay? This is weight. Tadi tu kita bincang pasal mass. Alright. Next, external force. X component, external force. It's in your X component je. Y component ada tak? Tiada kan? Alright. So, you don't know the value. Just write F. No worries. Fx pun boleh, F pun boleh. Sebab Y component kosong. Okay, next. What do you do? You will be doing your tension. Sebab kenapa? It is a crane, hung. The moment hung, which means it can be cable. Here, very obvious cable. Tapi sometimes dia takkan cakap cable. They will just say hung. Hang tu gantung. Kalau gantung, sure you'll be using a cable, rope or string or whatever. Okay? Definitely there'll be tensional force. Now, remember, you dah tarik you punya tension force ke atas. So, kalau macam ni, tadi diagram dia macam ni kan, tension dekat sini, Ty Tx, negative T, cos 60 degrees, here will be positive T sin 60 degrees. Okay. Next, what do you do? As usual, we know very well, total of forces untuk X dengan Y sepatutnya kosong. Alright? Next, what do you do? You have to find, what is the question? Refer back the question, magnitude of tension in the cable. So, tension dekat belah mana? Tension dua-dua belah ada kan? Tapi, what is the easiest side for you to find? Okay. First things first, it's best for you to write EFX. What equation dulu? Equals to 0. So, F kosong tambah F tolak T cos 60 degrees equals to 0. This will be your first equation. EFY equals to 0. So, negative mg tambah T sin 60 tambah kosong equals to kosong. Okay? mg, you can open it up. Kenapa? Mass sudah diberi dekat sini. You have 250 kilos. So, you just put in 250 darab dengan 9.81. Okay. Over here, it is given G equals to 9.81. So, jangan guna negative 9.81. Guna 9.81. Kenapa? You dah letak dekat sini negative. So, don't worry about it. Okay. So, over here, outside negative, tambah T sin 60 degrees equals to 0. Now, you can actually get your value of T kat sini. Kenapa? Sini 2 boleh buat calculation. Sin 60. Can you find T sin 60? T sin 60. Let's say you have a value over here equals to 2. T sin 60 equals to 2. You can just bring the sin 60 over, divide it, you'll get your T's answer. You'll get your tension answer. So your answer over here for T will be 2833 newtons. I want you guys to try and show me the working step by step, okay? 2833 newton. Now, let's move on to question B. Okay, For question B, dia cakap apa? Magnitude of the horizontal force. Basically yang ni lah kan, horizontal force. So what do? You dah ada, remember or not? You guys have already got the equation, first equation, second equation. Value for T pun sudah ada. Okay. Value for T ni, masuk je lah dekat sini. You get a value cos 60 equals to 0. Kenapa? You nak find force dekat sini. Just put in the T value, get the value of the force. Okay, so your value of your force will be 1417 Newton. Okay, guys, I would like you guys to try out, retry all these two questions. These two questions basically, this one, notes very important. Number 1, number 2. Okay, I'd like you guys to retry this question. Show me the full working answers. This question, full working answers. And this one, I would like you guys to try this question too. Okay, let me give you guys the answer. For A, the answer would be 14.6 Newton. And for B, it will be 9.39 Newton. Okay, these 3 questions, and I'll be giving you guys 1 or 2 additional questions as homeworks for you guys to try out. Okay, guys, I hope you guys enjoy this session. If there's anything, you guys can just drop me a text. I hope you guys learned a lot for today, and we have 2 more Newton's law of motion that we're going to look at in details. Don't worry about that. We'll come up with that in the next session. Okay, guys, see you soon. Happy study.